Please welcome Diana Scharf.
Hello, LARACON. First talk is done. I hope you're not too hungry after hearing the talk of the pizza overlord himself. I'm, as always, honored to speak at LARACON. And especially today, I'm very happy that I'm this early in the conference, because I know how it is this evening. You will have some dinner with friends, and then a drink, and then another drink, and another. And tomorrow, your brains will be very tired, and your brains will be pretty challenged with the topic. We are going to talk about word embeddings, but before we start, my name is Diana Scharf. As Kaneko mentioned, I'm from Germany. I hail from the land of pretzels, Bavaria. And it might be an unpopular opinion, but beer is not the best thing from Bavaria. Pretzels are. Yes, I am the full-stack code witch at Beyond Code. Some people say a full-stack software developer, but that's boring. And yeah, we do all kinds of great things. For example, Tinkerwell or Laravel Herd, which is great. And yeah, so if you want to know more about me, just at the moment, go to Blue Sky. Who knows which social network will be tomorrow? Or check out my Pinkery links or my website, but that is about me. And before we really start to dive into the rabbit hole of embeddings, because it is a rabbit hole, a little disclaimer. We are going to do low-level word theory here. Low level in the sense that I am not a data scientist. I am not a mathematician. I mean, I do have an engineering degree, technically, but I'm just a developer like all of you. And I am excited about embeddings, and I'm excited about working with them. So I will simplify a lot of things, because you don't have to be a data scientist or an expert or whatever to work with embeddings. Good. With that out of the way, let's get the elephant out of the room and answer the question, what the heck is a word embedding? And each time someone asked me today, yesterday, hey, what you're talking about? Yeah, word embeddings with Laravel. Ha. That's great. You don't know what a word embedding is, right? No. And I'm pretty much sure that a lot of you also don't know what a word embedding is, and that is completely fine because it's very niche. So to answer the question very simply, a word embedding is a vector representation of a word. And that is still pretty abstract. So before we go to why we need word embeddings and what we can actually do with them, let's look what they do on a higher level. You might notice that everything that has to do with AI at the moment, be it ChatGPT or DeepSeek or whatever, seems extremely intelligent and aware of what we humans want most of the time. But actually, computers don't understand what we want. But what computers understand is math. So embeddings, word embeddings, help computers to work with human semantics. Again, a word, semantics. What is semantics? Not everyone might know this. We all know the word syntax, I guess. Syntax is how you have to write your code so it works, at least syntax-wise. And syntax is something that also exists in language, in English, in German, you name it. But semantics is very different from syntax. Semantics is a science that is about finding out what and why a symbol or a character or a bunch of characters, so a word, means what it means to us. For example, what is a cat? When I think of cat, I think of something like that. A fluffy black ball, thinking about world domination. So the English word is cat. Since I'm from Germany, the first thing I might think is Katze, which is German for cat. But someone who was raised in Japan might think neko and think of the kanji instead of a bunch of characters. So semantics is exactly that. We say katze, cat, neko, but we all mean the simple black fluffy ball. That is semantics of a cat. Good. Usage of embeddings. So when we teach computers to understand human semantics with math, what can they do for us? Bunch of things. We can do semantic search. We can do content moderation. Because if I'm writing a comment like, you are a potato, the computer might not think that it is offensive, but in human context, mostly it is offensive calling someone a potato. We can do text classification and clustering and text similarities. They all play kind of into the same thing, which is like finding similarities between texts and inside of texts. But I bet 99% of you, except Bert, where's Bert? Except this guy, is triggering an embedding each day. Every time you type something into ChatGPT and ask why your code isn't working, it will use embeddings, along with a lot of other things, of course, to find out what you actually want from it. So embeddings are more in your world than you might think. Good. A word embedding is a vector representation of a word. We now know what it is, kind of, and we know what we can do with it. So, what is a vector? You might remember something from school, something like that. But also, that is a vector, not the podium, my arm. My arm is a vector in this case, because it has a magnitude, so kind of a length, and a direction to the podium. And vectors can exist, so a vector is a quantity with magnitude and direction in an n-dimensional space. A quantity is something we can measure. And we as humans can imagine vectors with 2 and 3 dimensions pretty well, but since vectors are mathematical entities, they can exist in any number of dimensions, and that is pretty important for later. So, how do we go from cats to something like that? For that, we need an embedding model. And there are a lot of embedding models out there. For example, OpenAI has 3. And to create an embedding model, we will not go into detail because we are at LARACON. This is not a data science conference. You basically feed a finite amount of text, that is important, a finite amount of text into an algorithm. And one thing that the algorithm can do is measure the distance from one word to all the other words in the text. And with that, the model kind of learns the context of each word. There are a lot of ways on how to exactly do that, but like I mentioned, we will leave that fun to the Python people. But you will see Python just in a minute, just a warning. Good, but just to give you an example how an embedding model, really much simplified, can be created. We will look at flying objects, so everything that moves in the air. And we will feed a finite and hypothetical body of text into an embedding model, and this embedding model will look at the context of these flying objects in the terms of wings, engine, and altitude. First word is a helicopter. According to our base text and the embedding model, the helicopter does not appear in the context of wings. Why? Helicopter has rotors and not wings. It, however, does appear in the context of engine and altitude. 0 to 3. 0 to 3. Yep, that is a vector. A few more examples. More flying things. A bird has wings. No engine, but it still flies. An airplane is pretty similar to a helicopter, but it has wings. And a bumblebee, well, a bumblebee justifies gravity and physics and everything else. It has wings, certainly no motor, and it flies. So, we have a lot of numbers here. If we take these numbers, these vectors, and plot them out into a Cartesian coordinate system with 3 dimensions, we can actually see the relations between the objects. You might notice that helicopter and airplane are on the same plane, you might see. And a bird and a bee are pretty similar to each other as well, down here, and not very similar to a rocket up there. And like I mentioned, we can actually see in this visualization with our own eyes the relations between the objects. The computer does not see this. A computer only has the vectors. And since vectors are mathematical entities, we can calculate with them. And therefore, a computer can do this for us. And we don't make calculations with vectors to find out how similar and close and angles and whatever they are. We let the computers do the work of sinus and cosine and tangents and all the horrible things from math class and just use the results to work with them. Good. Word vectors in the real world have more than 3 dimensions, because human context is a difficult thing. And this map, I will zoom in just a second, shows the context and relations of animals in 300 dimensions. So you cannot plot this in a coordinate system anymore. And if I zoom in here a bit, you see that in this corner is the word pet. Here is dog, pretty close to pet, but because a dog is the pet. Evolution did the dog for us humans. And it is also close to home. But cat, however, is closer to fluffy than to pet. So the question is, are cats pets? Because maybe there might be a hidden node in this graph which says world domination, who knows? And yeah, if I go up there, top left corner now of the thing, you see that a hamster is also kind of in the middle, down to pet, but also close to mouse. Because in some cultures, it might be that a hamster is more like, a rodent, or not really a pet. And you see, for example, an elephant is very far away from a pet. Who has an elephant as a pet? I do have PHP elephants, but that's not the topic here. And so you see, cats maybe are pets, maybe they are not. And like I mentioned, we can calculate with vectors. Therefore, we can't calculate with words. And there is a very famous example in this whole space. So if you know the result of the equation, please don't ruin it for all the others. We take the word king. We subtract the word man, so male human being, and add the word woman. Any ideas? Sorry? Perfect. Smart people. Yes, that's a queen. Think a minute about it. It will make a lot of sense. But still, a lot of theory, a lot of math. We're PHP developers. We already have function in PHP to compare texts and words. Why don't we use these? Going to show you. But before we start, we need to be on the same page. We need to agree that a cat and a dog have more in common than a cat and a car. Okay? Good. So, switching screens, I can do this. Wrong screen, fine. Perfect. Good. So, sip of tea. Here in Tinkerwell, I have one example of a function PHP comparing words or strings. And the Liebenstein function implements the Liebenstein distance. Liebenstein distance is a minimum minimum number of operations you have to do to replace, insert, or delete to transform one string into another. So the higher the value here, the less similar the words are. And if I run this for cat and dog, I get the value of 3, and for cat and car, I get the value 1. So according to the Liebenstein distance, a cat and a car have more in common than a cat and a dog. But PHP literally has a similar text function. And again, it returns the number of matching characters in both strings, and you see cat and car don't share any character, but a cat and a car share 2. The Levenstein distance is great for different things, for example, finding typos or something, but comparing characters, when it comes to comparing semantic of words and things, doesn't make any sense. And for that, of course, you might have guessed it, we are going to use embeddings. And we will use the embeddings endpoint of OpenAI later. But before we do that, I fell into a rabbit hole, like I mentioned. And during my research, I saw some things. So we are going to do a very short detour into Python land and work with a real embedding model. Everyone's fine seeing the code? Yes, good. So this very first cell in this Google Colab notebook is downloading an implementation of the GLOVE model. GLOVE stands for Global Vector, and this was an open source project from the University of Stanford around 10, 11 years ago, so embeddings have been around for quite some time. And even if it's not that recent, this model was trained on the Wikipedia text of 2014 and Gigaword, so that's basically Twitter and some news feeds. It is a very good starting point to play around with embeddings. I already executed the first cell because you need to download the model, and that can take some time. And this model has a similarity function, and takes 2 arguments. And with that, we can compare a cat to a dog. And this function will return a value between 0 and 1. 0, not similar at all. 1, basically the same thing. Any guesses? I don't hear a thing. 7, what? 0.9. So according to the GLOVE implementation, a cat and a dog are pretty similar. So just to make it complete, a cat and a car. More guesses? 42. Have you ever seen a cat? 0.36. I mean, I guess a cat and a car, yes, they exist on planet Earth, both together. At least for the car. About cats, I'm not sure if they have expanded in the universe and haven't told us about it. Yeah, but you see, it makes a lot of more sense to use embeddings to actually compare semantics of words. And the cool thing about the model is it comes with the most similar cosmil function. Cosmil is short for cosine multiplication. I'm not going into detail. And this function takes positives and negative. Positive is king and woman, because these were the things that are adding in the function, in the equation, sorry. And negative is man. And this function will return a list of words along with the similarity value that are closest to the result of this vector calculation. You might have guessed it. The very first entry is queen with 0.9. So this is a real calculation with words and vectors. Good. Back to that. So, how can we use embeddings with Laravel? Because this is what you want to know. Like I mentioned, we are going to use the embeddings endpoint of OpenAI. Just a short note, you need an API subscription for that, so only ChatGPT will not be enough, as far as I know. And currently, OpenAI offers 3 embedding models in version 3, small and large version, as well as the Ada version, the Ada model in version 2. And these models differ in price per 1 million of tokens that are processed, and of course in their performance. Performance for these models is measured in MTEB. MTEB is Massive Text Embedding Benchmark, and it does all kinds of things like measuring the performance of these models in terms of text similarity and clustering of text. And while 60%-ish of performance might not seem very high, it is pretty good. You can use the large model for tasks with a high accuracy, but it is pretty expensive. And the Ada model is, according to OpenAI, and they're very detailed write-up on their website about these models, the best compromise to get started with the 3. And with that, congratulations, you have finally met Ada. Not only this model, but also before the whole renaming thing happened, the Embeddings endpoint was named after Ada Lovelace, this inspiring, amazing woman living in the 19th century who told herself, with the help of a teacher, math, which was not accepted by society at the time for women. And next to that, she just casually wrote the very first computer algorithm ever without even having a computer, because all that existed at that time was the theoretical model of her friend Charles Babbage. I guess women in tech, we're always kind of the crazy people. Good crazy, of course. So, with that, back to more endpoints. You cannot send thousands of pages of text to these endpoints. There's a limit. And per request, that limit is 8,191 tokens. And a token is not a character, and you might have heard of the term token usage whenever you have to figure out how much you have to pay OpenAI each month. And a token is a sequence of characters converted into a numerical format. OpenAI's tokenizer is called TickToken. It's, of course, written in Python. But there is a port for PHP as well, which we will look at now. Good. So, this is a resource list for this tokenizer. And you see it's basically a very long string of words and word parts with numbers. So, for example, you see the word, I don't know, the word part OOK, like in webhook, for example, but also common words like very. Oh, sorry. Believe me, very is somewhere in there. And with this tokenizer, we can tokenize an example string. Hello, LARACON EU will result in these 5 tokens. Hello, very common word, so it has its own entry in the list. EU as well, abbreviation for Europe, you name it. And of course, exclamation mark as well. LARACON, however, for normal people, it's not a word, not a common word, so it is made up of 2 word parts. Ignore the funny G's, that's just an encoding thing. However, when we work with embeddings or tokens in general, we are not interested in an exact number in the list, which token is which one. We just want to know the number. So we can, of course, call the count method as well and pass the embedding model that we are going to use, because tokenization differentiates between different models, and we get as well 5 tokens. But no one is going to embed the string hello LARACON EU. So let's look at a longer text. Laravel documentation, collections. Who has ever read through the whole collections page? Some time ago, but yes. So this wonderful document, it's a markdown that I downloaded, has around 12,000 words, which results, according to the tokenizer of OpenAI, in 30,000 tokens. So you definitely have to split up this page if you want to embed it. And all in all, it's still the cost, US dollars, 0.0029-ish. Not very much, because embedding models are very cheap. And as soon as we send something to the OpenAI endpoint, this will be the response. That is a vector. So basically, a very long list of numbers, 1,536 in this case, to be exact. So now we have a vector. What are we going to do with the vector? Storing it would be a great idea, I guess. As Laravel developers, our easiest way to store a vector is by using a Postgres database that comes with the PGVector extension. And this is integrated in Laravel Herd as well. Not that I had my hand in adding the PGVector extension. And it's pretty easy to set up. You can start right away. It comes with a few handy functions that I will just show you. Technically, you can store vectors in other databases as well, MySQL, SQLite, and do the vector calculations in PHP, but that gets very slow, very fast. So we better stick with Postgres. And like I mentioned, this PGVector function extension comes with a lot of very handy math functions in the database, directly in the database, that can help us to work with vectors. And that also extends Postgres by a vector data type, exactly for this use case. And of course, we can add an index to this vector column, and that is another topic which I will not cover today because that is a lot of fine-tuning included. So, I did, after some research, and when I just looked out of the rabbit hole, something that every excited developer does. I created a package. It's far from done, it's far from perfect. But, you know, exciting developers doing exciting things. The Ada Laravel package lets you get started with embeddings right away in your Laravel app, and you can create embeddings for your models simply by using a trait on the model, the hasEmbeddings trait. And with this hasEmbeddings trait comes a method that lets you embed content about your model. So I'm having papers here because we are going to look at a demo website just in a second. And we simply call the embed method on this paper model, give it a key for our reference, so what are we embedding about this model, and then, of course, the content that we want to embed. And like I mentioned, our demo website is this little website of the Ada Lovelace Institute for Digital Wildlife. And this website contains papers about, for example, the PHP elephant. It's very fascinating. And each paper, of course, has a title and then content and nothing more, because we just need some example text to work with. And like I mentioned, we can use the embed method to embed the content of a paper. Tokenization can take some time, which is why I did this beforehand for all the papers on this website. And instead, I'm going to show you what this method does under the hood. So here's the trait and the embed function. Key and content are coming in as parameters. And the first thing that this method does is pulling an index class from the app container. And this is because this package is not specified for OpenAI. If you want, you can implement your own index for, let's say, OneEdge.ai and use their embeddings endpoint. And the index implementation is an abstract class, and it contains everything that you need to work with a certain type of embedding provider. So, for example, of course, the API methods to actually call their endpoints, as well as tokenization is also different for each model, and splitting the text into parts to send them to their to their endpoint. And after we did that, the index will, with help of the tokenizer, split up our context into embeddable chunks. So 8,191 tokens-ish maximum. And this will return an array of embedding Laravel models. It's important, so I don't lose you. This is not an embedding model, it's a Laravel model that is coming with the package embedding. And we're just creating the reference to the Laravel model that we called the method on, because this is a morphable relationship in the database, so for the type and the ID, and then we just save it with the content and dispatch a job. And this job will simply call the embed function on the index, and this is basically doing the request to OpenAI, hey, give me my vector for my text. And like I mentioned, I already did that for pretty much every paper on this website. So for example, the very first one, paper relation, ID, the key, what are we embedding, the text of the embedding, and yes, here's a vector again. So that's nice and all, but what do we do with that? Long list of numbers, I cannot read that. But what I can do is ask a question on this website, because this is a semantic search. I want to know, where does PHP elephant live, so I can get some more. Oh, a PHP elephant thrives in silicon forests, rich in data streams. Its diet includes mineral-rich plants like conductive bamboos. So you have to believe me that if I would cross-check that with the paper, it is not a one-to-one copy. But it's right. It just is an answer to my question based on the embedding of this paper. And this is not a wide-like search. This is using embeddings. So here is, first in Tinkerway, so you can see what we're actually doing. Here are two ways to use the semantic search. I called the method for the semantic search lookup, to not get in the way with Laravel Scout and the search method. And because it is more than just a search, it is like looking up information in a library. And this method takes just the query if you want, but you can further customize your search by passing a custom prompt, which we will get in a second, or you can just limit the search, the vector search, to a certain type of models by passing a callback. So if you want to, for example, only look for embeddings related to the paper class. And at first, also, this method pulls an index, because we, again, need to embed something. We need to embed the query. So where does the PHP elephant live? What is the context and the semantics of this question? And we will get back a vector. And with this vector, we can perform a nearest neighbor search on the database. And that is here. Okay. And this nearest neighbor search, basically, it's running in Postgres, so it's very fast. It looks which vectors are most similar in terms of angle to the vector of our query. We're using the cosine distance here, not going into any detail, because OpenAI says it's the best when working with their models, so I'm doing that. And we get a list of vectors, of course, that are closest to our query vector, and we take the first one. And with that result, we don't only have the vector, we have the content as well. And with that content, we can create a prompt, and you might have seen a prompt like this before. You are a chatbot that helps answering questions based on context. And that is the easiest task for each ChatGPT endpoint, because we're going to send this prompt, replace the placeholder with the context from the database, of course, and we're going to send it to GPT 3.5 Turbo. Yes, this old thing. And this will exactly return the result that you just saw on the website. Good. Play, please. Perfect. And this is everything. That's a basic flow of implementing a semantic search into your Laravel app. It's that easy. Of course, you have to start by embed the query or question, and then you perform the nearest neighbor search. You could stop there. You could just show the most relevant papers for the question and let the user find the answer by themselves. But of course, you could send it to a generative endpoint as well. Like I mentioned, this talk only scratched the surface of what you can do with embeddings. There is a lot more to talk about in terms of fine-tuning the vector depth and which model to use and which distance to use. But it's a very exciting topic. There is a lot of excitement going on in our space about how intelligent AI is and what you can do with ChatGPT, and that is true. It's exciting and sometimes morally gray, but it is great technology-wise. But embeddings are a different kind of intelligent. Embeddings allow you to make your app intelligent in your very own app's context. You can build better content moderation. You can just try to understand your users better. And every time I talk about embeddings, I get goosebumps because I'm very excited. But thank you. Happy embedding. Talk resources here.
I have questions.
Oh, yeah.
So first question. First question comes from Lucas. He is asking, how does word embeddings handle words with multiple meanings? For example,
Again.
come closer. So how word embeddings
Yes.
handle words with multiple meanings? For example, bat, as
Yes.
being a bat,
Yes.
or bat?
Yeah, like in a baseball bat.
Yeah.
So basically, that is exactly the thing. It's depending on the context of the initial text. So if you, for example, feed the embedding model a text that is only like about animals and wildlife and whatever, and not about sports, so a bat is always that, a bat. If you like feed it a whole library where everything is in it, animals and sports and whatever, it might create either two vectors for bat, that depends on how exactly the model is working, or it will then, that is a fine-tuning thing, and you will have to use the right vector distance to get the right result. So that is very depending on the model and the fine-tuning.
So it depends.
It depends. I can talk like 2 hours, it's fine.
I'm used to that excuse, like, it depends.
Depends.
Depends. So this question is from our friend,
My
the
best
anonymous user.
Yes, my best friend, yes.
So the anonymous user is asking, from the word similarity,
Yeah.
is pretzel a cookie? Can we check it?
Okay.
Or you have the answer right away?
I don't know, I did not check. I have no idea. So, according to glove model, we can see if it works. Ooh. Maybe
Almost.
not that much.
Almost. Thank you for your talk. Please, a big thank you for Diana.
Thank you.
Thank you.